Hello, I am Saranya Chiriboma and my topic for the presentation is support vector machines in statistical machine learning. Speaking of the history, a machine learning is a method of teaching computers to make and improve predictions or behaviors based on some data. It can be defined as a field that involves computers and their ability to acquire and integrate the knowledge automatically. A general machine learning system basically starts with some amount of knowledge and a corresponding knowledge organization so that it can interpret, analyze, and test the knowledge acquired. The data can be in any form such as a sequence of inputs or a sequence of outputs or a sequence of readings from a robot sensors, etc. Another way to think about machine learning is pattern recognition. A pattern can be defined as something which says about the probability of the distribution of variables, and recognizing such patterns is called as pattern recognition. The idea of using pattern recognition to make generalization lies at the heart of statistical machine learning, which was started by Wapnick in 1960. It is a theory about machine learning from a small sample size. The standard tool for pattern recognition, which has been very successful in the domains ranging from computer vision to computational biology, is support vector machine. That can be described in simple words as a mathematical entity or an algorithm that analyzes data and helps with recognizing patterns. A basic system of support vector machine takes in a set of input which is generally comprised of data, and then it predicts for each input the set of output classes. SVM can be applied when finding fraudulent and non-fraudulent credit cards, recognize handwritten digits by examining a large selection of scan images, etc. It is a learning technique for pattern recognition and regression estimation, as already said. The solution provided by SVM is theoretically very elegant and computationally very efficient. It has a simple geometrical interpretation in a high-dimensional feature space that is non-linearly related to input space. This slide shows vectors x and vectors y and the product of vectors x and y and their results. In the slide, the boundary line of the decision is shown for x plus by minus c. Some methods find a separating hyperplane, but which is not optimal. Support vector machine finds an optimal solution for this problem. This support vector machine maximizes the distance between the hyperplane and the difficult points close to the decision boundary. This diagram shows two planes x1 and x2 and two separate classes green and red which denotes +1 and -1 and a decision boundary lines of different points. In this slide, the different boundary lines are shown and the gap between them is called as margin, and the weight vector W is shown, and L, which is the number of data points of xi, is shown. The margin gamma is calculated using the formula yi of w into xi plus b for any given point xi yi. And if gamma greater than 0, then the example is well classified. The margin gamma is the minimum of the margin distribution with respect to the training set. For maximizing the margin, the distance between h and h1 is calculated using this formula for any point x1, h1, and the distance between h1 and h2 is calculated by using this formula. In order to maximize the margin, we need to minimize the W. And the selection and this slide is the objective for a selection of a good hyperplane. To select a very good hyperplane using only the data, assuming the linear separability, should separate the data and place the hyperplane far from the data. This slide shows the applications of SVM. One of which is very important application is phase detection. In phase detection, in a component system, the visual components are located first, extracted and combined into a single feature vector, which is classified by the support vector machine. The second very important application of SVM is object recognition. For scalable search through a large database, image features are quantized using a scalable vocabulary tree, which is called SVT, which forms a large visual dictionary. Support vector machine is designed as a classifier for tree histograms calculated from SVT quantization. This slide shows the other applications of SVM like the handwritten character and digit recognition, the speaker and speech recognition, the image retrieval, prediction, and data compensation. Hence, this explains the introduction of support vector machines using statistical machine learning. Thank you.